Hello, this is the video solutions for freshman summer problem set 11, rates, ratios, and proportions video. So yeah, I waited again to post the solutions because these problems were pretty hard actually. I feel like they were hard in the sense that if you like you would kind of be you'd think that you'd have a solution because it's like all of it's just algebra, right? All of it's just concepts that you already know. So you might be like, okay, I know how to do it. So like you'll probably spend a lot of time on these problems because you'll be like, oh, I have the tools to solve it. Now I just need thinking. But with past ones, you might have not necessarily known what to start. But these ones, I think, were all approachable, but they're still pretty challenging. So, yeah. Okay. Whew. First one. Um. So when you think of averages, think of always the formula for an average because that lets you put in nice stuff, right? So average age of the female members. That means number of females, or no, sorry, the sum of female over the number of females. So I'll just call that F is equal to 40, and then the sum of the males over M is equal to 25. Now when you combine the sum of the females and the sum of the males, right, sum of all, and divide that by the total number of people, which is males plus females, that's going to equal 30, right? And how does this help? Because if we multiply this over here and that over there, right, you'll get the sum of the females and the sum of the males. So we don't know that number. It's just another unknown variable. So I have 40. So here, so 40f plus 25 male is equal to, I'm going to cross multiply it out, so 30m plus 30f. Now this is pretty easy to find the ratio because combining like terms gives you that the ratio, we have to find the ratio female to male, right? And so when you have that, female to male is just the same thing as f over m. And so yeah, f over m, just do f over m is equal to f over 10, which is equal to 1 over 2. So 1 over 2 is your final answer. Okay. Moving on. This one's really short, and it's really easy to do if you know the harmonic mean formula that I've probably mentioned before. So basically, I think this is going to be the last time I'll ever show this proof per se, because I've done it a lot of times. I can kind of recap, but yeah. So pretend you're like this, right? So you're basically going up the hill. So the reason you can't just average the speeds and say, oh, 15 is your answer, the reason you can't say that is because you're basically traveling those speeds at different times, right? You have, so if you remember, average speed is just total distance over time, right? Why? Because if you move over time over, you just get d equals rt, which makes sense. So for the distance here, we'll just call that d. It doesn't matter what it is, right? And call that d. The speed, if you do d times 10, d divided by 10, and then d divided by 20, those are the times. So now we have a total distance of 2d, because we're going 1 here, 2 here, over d over 10 plus d over 20, right? That's equal to speed. Now, the nice thing is, all of these terms have d, so now you just have a 2 over 1 over 10 plus 1 over 20. And if you recall, that's just the same thing as the harmonic mean. I could just say, oh, it's the same speed, so boom, already 2 over 1 over 10 plus 1 over 20. And then you're done, right? Same thing, just one is like a formula for shorthand and the other isn't. So this is just going to be 2 over 30 over 200. So that is just 2 times 200 over 30. This cancels out with this. So 40 over 3 is your final average speed. So yeah. Okay, now we start getting to the harder problems. These are pretty interesting problems too. That's the nice thing about these. really get you in the mindset, right? So basically, this one is pretty interesting because like you have to use a lot of variables, but it's nice because it all just turns into a system of equations. The nice thing is a lot of rate problems do turn into system of equations in the end of the day. It's really nice. So I'm just gonna say Tom speed, Dick's speed, and then Harry's speed, right? Now, think of it this way, right? Just like D is equal to RT, the sum of distances, so sum of D, can also be represented as a sum of your different rates. So I'll just say like Ri times the time that you travel at that rate, right? That makes sense, right? Because think of it like this. Say I'm going on like a path, right? I'm going, this one's 10, this is 20, right? And I'm going at a speed of like 5 mph, and then this one's like 10 mph, right? If I want to find the total time it took me, it'll just be 5t1, which is equal to 10, and 10t2, which is equal to 20, right? And then like you can like also represent it as the total time 5t1 plus 5t2 is equal to 30, right? That all makes sense. So using that principle, let's start problem solving. So for Tom, right, let's think of Tom's perspective. So this guy, he got in an automobile, so he's traveling at a smooth rate of 25, and we don't know what time, so I'm just going to say time 1. The reason I'm not using A, B, C, D is because I like having T sub 1 help me a lot more. So 25T1, now what happens? Well, this guy, he walks, right? He's walking at, I don't know what time it is. I know it's not the same as time 1, so I'm just going to say time 2. And this is 1D, right? This is another distance. And together, it makes a total distance of 100 miles. All right, cool. So yeah. Now, I'm only now realizing how long 100 miles is, actually. That's a lot of walking. But yeah, okay, now let's think of... Oh, it's not even in order. Okay, let's think of Harry's perspective. Why? Because Harry is on the automobile. Okay, so Harry, he went up on the automobile, started off at 25. For how long? Well, same time as Tom, right? Because now he's still in the automobile, but he's going back. So you got to ask yourself, is that a negative or positive value? Because think of it on the trip, right? Here's like your nice road. Harry's like this. Now, boom, he has to go back. So we have to account for that change, right? And it's pretty easy to realize that, hey, that's just subtracting, because think of it as net distance. Net distance traveling is decreasing because he's going back. So that's 25. Now, how long? Is it time 1? No. Is it time 2? Not necessarily, because we're never told that he's like, he doesn't reach, actually no, we know for a fact it can't be T2, because when he's going back, T2 is the rest of the trip after T1, but we know that he reaches at the same time, so it has to be smaller than T2, so I'm just going to say another variable, T3. Now, he's going on the automobile at 25, and like I said, I don't know what time it is, so I'm just going to say T4. And this is also equal to 100. And now you might be like, wow, that's a lot of variables. But I'll show you something cool. But, yeah, so another thing we're going to also show, I'm just going to erase this, that's fine, but something that's noticeable is that T3 and T4 make up T2. And it's pretty easy to prove this because these two are the same, so that just gets all the math out of the way. So I'm just going to write on the side, T2 is equal to T3 plus T4. Now, Dick's perspective. So this guy, he's walking at 5. For how long? I don't know, because it's not T1, because he's walking he's still walking by the time Harry's on his way back. So I'm just going to call that T5. But now, he's in the automobile and everything's cool. And is this a new variable? No, because it's just this, because now he's with Harry. So it's just T4. So, and then T5, well, can we express that? Yeah, we can. T5 is just going to equal T1, because it's from here, and then plus T3. And we can prove that the same way we proved how T2 is equal to T3 plus T4. Okay, so that was a lot of talking. And now what? Now what do we do? Well, I don't like how we have 1, 2, 3, 4, 5 variables in 3 equations. However, we can make some nice substitutions. So let's look at it. Is there any variable that shows up in every single equation Yes, because if you substitute T5 and T2, T1, T3, and T4 will all show up. So I'm going to go down here and rewrite my equations as 25T1 plus 5T3 plus 5T4. How do I get that? Because T2 is just equal to this, and that's just substitution, right? And then distributive properties, that's equal to 100. Now, 5T5, so 5T1 plus 5T3 plus 25T4 is equal to 100. And then I don't even have to substitute for the last equation because 25T1 minus 25T3 plus 25T4 is all equal to 100. Now we have 3 equations and 3 unknowns. So now it's just as easy as solving the system of equations. And we're going to do one more thing. I'm just going to divide everything by 5. And on paper, you might want to do this as just another line. But I have the whiteboard, so I'm just going to take advantage of that. And yeah, so why am I dividing by 5? Because it literally just makes my life easier. That's pretty much it. All right. Okay, so now that we have that out of the way, now how do I solve this equations? I don't know. So we instead of trying, there's a nice way called Cramer's rule, but it's kind of like more advanced, so I'm not going to go over it. So let's just look for clever things we can do. So I'm thinking, well, I can notice that if I take the first equation and the second equation, I can combine them so that my T1 and my T4 are in the same ratio. Have a ratio of 1. And why is that cool? Because these also have a ratio of 1, so I can cancel them out. So that's just something I saw. So combining equations 1 and 2, I'll just number these. Combining those will give me 6T1 plus 2T3 plus 6T4 is equal to 40. I'm going to divide that, so it's really nice for me. And then this 3 and this 3, right? Now, 5T1 minus 5T3 plus 5T4 is equal to 20. Notice how if I do 5 times this, right, and then 3 times this, right, you'll have to do the same on both sides. You can actually cancel your T1 and T4. That will just leave you with T3. So I know that, so I'm not even going to bother doing the arithmetic with this. I'm just going to cross them out. So 5T3 minus, and since I'm subtracting, cancel that to plus, or wait, yeah, yeah, okay, 5T3 minus 3 times 5, which is 15, T3, is equal to 20. Okay, think of it this way, right? You don't even have to do the computation. If you have 5 20s and you're taking away 3 20s, you're only left with 2 20s. So I'm just going to say 2 times 20, right? And so that just gives me 20 T3 is equal to 2 times 20. And it's nice because the 20s cancel out. So T3 is equal to 2. Now, that's huge because now we just found one piece of the problem, but that turns all our equations really easy to solve. So I will just plug this into the first 2 equations. So 5T1, and I'm moving over the 2. So 5T1 plus T4 is equal to 18, right? I skipped a step, but I hope it's kind of like makes sense where I got that. Now, T1 plus 5T4 is also equal to 18. And now I realize that, hey, something is cool. If I add these, you'll notice that you'll end up getting T1 is equal to T4. And I did this because, sure, you're not going to get it solved on the first one, but now that's pretty huge. Because if T1 and T4 are equal, then you can just do 6T1 is equal to 18, and conversely 6T4 is equal to 18, right? I'm just substituting one over for the other. It doesn't really matter which order I do it in, but both T1 and T4 are both equal to 3. So now, what are we solving for? We're solving for the total amount of time. I should have specified that earlier, but the total amount of time, that is just T1 plus T3 plus T4, because you're guaranteed to be spending that whole time to get to 100. So that's just asking, what is 3 plus 2 plus 3? And that is the answer of 8. It's a pretty long problem, but I wanted to explain everything because it's a really nice problem. So yeah, okay, I'm going to wait for it to delete, but okay. So yeah, this one is a bit less computationally heavy. This one is just ratios, right? So wins over total at first is equal to 0.5. I'm just going to write 1 over 2 because it's pretty nice to do it, right? It's nice to have fractions instead of decimals in this case, right? Now, she plays a couple matches, so now she has 3 wins under her belt, but now she has total, how much are added? 4. So that is not defined to be a value, but it is greater than 0.503. So this is nice because we have a system of equations, kind of. One of them is an inequality, but it's pretty easy to substitute because we're looking for 1, right? So we kind of we need to basically solve for winning in this equation and define an inequality. The nice thing is 2 times your wins is equal to the total, right? That's your initial. So because of that, I can make a really nice substitution saying that win plus 3 over 2 times your wins plus 4 is greater than 0.503, right? And I guess I could substitute win for W. I'm just going to rename it to W. So W plus 3, also moving over this to that side, 0.503 times 2W plus 4. Okay, this looks pretty hard to do, but bear with me. This is kind of just like arithmetic. So W plus 3 is greater than, what's 2 times 0.503? Well, if 2 times 0.5 is just 1, you're adding that 0.006. So you just have 1.006W plus, and then twice that, because 4 is twice of 2, 2.012, right? And I'm nearly done. Now I just have to solve it accordingly. Moving that W over, that'll just give me 0.006W is less than, moving this 2.012 over, 3 minus 2.012, what's 3,000 minus 2012? That is just going to be 0.988. And I could turn this into a fraction, or I can notice that both of them have 3 decimal places. I'm just going to multiply by 1,000, so 988 is greater than 6W. Now I just divide both sides by 6. That's just 1, 3, 6, 2, and 4. Remainder 3, or remainder 4, which is just like plus 4 over 6, is greater than W. Now the reason I write it like this is because it has to be less than this value. But thankfully, it is just the you know that a win is an integer, so you can just scrap this out and say that 164 is less or greater than or equal to W. Your max value for W is just 164. All right, so that is that problem. Now the last problem is kind of in the same theme of, oh, you need system of equations to solve. Okay, so yeah, all right. So basically, you got this, right? Now, the nice thing is that you have 1 biking rate, 1 jogging rate, and 1 swimming rate to worry about. So I'm just going to represent these 2 equations as situations, right? So for Ed, right, this guy, and this is the same theme of representing a distance as a sum of littler distances, right? So using d equals rt, right, you can just turn each of these into smaller d equals rt. So for Ed, he bikes for 2 hours, so the rate, so 2 hours times the rate of biking, which I'll just call b, plus 3 times jogging, plus 4 times swimming. What is that equal to? That's equal to the total distance of 74. Now, Sue, on the other hand, Sue does jogging for 2 hours, so they kind of try to trick you by having the order different, but I'll just write it as 2j plus 3s plus 4b, right? That's equal to 91. Well, we look like we're in a predicament, right? We look like we don't have that extra equation, because if we had that extra equation, you could make a system of equations and then solve for the variables, but you don't have that. But that's where this information comes in clutch, right? You might be thinking, oh, that looks kind of useless, but knowing that they're integer solutions, you can actually, these are called Diophantine equations, right? They're integer solutions only. For example, because they're integer solutions, and also, better yet, they're positive integers because they're rates, we can actually narrow down our solutions a lot. So the strategy you use is to just take 2 variables and try plugging it, right? So I don't know what's the easiest to cancel out. I just know that, hey, I can pretty much cancel out a variable really easily if I just multiply this equation by 2. So I'm going to subtract 2 times the first equation, so 4b minus 6j minus 8s minus, well, 144. That cancels out this, gives me negative 4j minus 5s is equal to 9 plus 47, or 44, which is 50, wait, oh, okay, yeah, then use something like fishy, okay, that is, what is 9 plus 48, that's 57, right? Something still feels wrong. Oh, okay, yeah, 57. Oh, that's because I forgot the negative. Okay, I was like, I had a feeling I did something wrong. So, negative 4j minus 5s is equal to negative 57. But better yet, I can just say, hey, 4 times j minus 5 times, or plus 5 times s is equal to 57. Now, this is nice, because let's think of maxes, right? If j was like 13, right, s would be 1. And basically, as j increases, s decreases. So now there's two things, right? The first was that they're positive whole numbers, right? So what does this mean? This means that 57 minus 4j must be divisible by 5. If I divide it by 5, it leaves a clean whole number. So that tells me one thing, that whatever that value is, 57 minus 4j, must end in a 5 or a 0. Why? Because that's a divisibility rule for 5. So now, can 57 minus 4j ever end in a 0, right? I'll just say like a 0, right? Is that ever possible? Now think about it. No, it's not, because 57 is an odd number. So to get an even number, 4j would have to be odd. And that is impossible. Why is it impossible? Because 4 is an even number, and anything times an even number is an even number. So therefore, 57 minus 4j must end in a 2. Now, why do I say that? Because that actually gives us a lot of constrictions on j. So we have j, and we can actually define a couple things where j can be, right? So if j is equal to 1, that's impossible, right? Basically, 4j must end in a 2. So what multiples of 4 end in a 2? Well, I have 12, I have 32, I have 52, right? And if that, and then j would have to equal 3, 8, and 13. And that's the only values, because if it was greater, then s would be negative, and that breaks the whole problem. So now I have 3 possible values for j. Now, what does this tell me about s? Well, we can actually straight up figure out what s is by just subtracting. So 57 minus 12 just gives us 45. That leaves s as 9. 57 minus 32 is 20, so s would be 4. And yeah. And oh wait, no, sorry, it would be 5, because I was just thinking you can't have that as an even number, because 57 minus 32 is 2. Yeah, okay, then 5, and then 57 minus 13 times 4 is just 5, which leaves s as 1. So now what, right? Well, this is really nice, because now we only have to find out b. We're already nearly there. We're just in the final stretch. And remember that 2b plus 3j plus 4s is equal to 74. Now, I'm going to do some more tricks, right? If I plug in this and this, 3 and 9, you'll see that 2b plus 3 times 3 plus 4 times 9 is equal to 74. Now, this now is b an integer. That's like, think of that, or think about that, right, for a second. Just can b be an integer? The reason I'm asking this is because not to like just complicate it, but to save time. Because right now I'm saying everything out loud. I'm saying my entire thought process out loud, but I'm thinking about this in my head, right? Like when I'm doing the problem, I'm thinking about it in my head and it goes way faster. But the reason I'm overcomplicating it is so you guys understand. So now, 74 minus 9 minus 4 times 9 is an odd number. Why? Because this is an odd number. An even number minus an even number gives you an even number, but then take away an odd number, you get an odd number. And no odd number is also divisible by 2. Therefore, b has to be a fraction. So that tells me that this is already an invalid set. Now, before even calculating the other like 2 possible things, I'm already going to tell you that it cannot be this. And that's for the same reason. because because j can't be an odd number if s is an even number, because then that means you're taking, like, for the same reason, right? You're doing 74 minus an odd number. So because of that, it can't even be this case. So now we know that j is 8. We know that s is 5. So I'm pretty much just going to erase this and then say 8 and 5. So 74 minus 20 minus 24 gives us 2b. Well, what is 74 minus 24? That is, why can't I do math? That's 50. Okay, 50 minus 20 is 30. So 30 is equal to 2b. So b is equal to 15. And wow, that's an integer. That's perfect. So now we have an integer solution with 8, 5, and then 15. So now what is it even asking? It is asking for the squares of b, j, and s. So what is 8 squared plus 5 squared plus 15 squared? That's just equal to 64 plus 25 plus 225. That's just 250 plus 64. That is 314. So 314 is your answer. So I know it sounds like I might have overcomplicated this, but the whole point of it is just so I explain my thought process, because you gotta, like, start thinking this way if you want to go fast, right? Like, sure, I spent, 26 minutes recording this video, but if you do all these tricks and you start thinking like this, these 5 problems will probably take you like 10, 15 minutes max. So yeah, that's pretty much it.